Hi everyone, hi classmate, hi sir. My topic is all about positive displacement methods, obstruction methods. A positive displacement meter are the only flow measuring technology to directly measure the volume of liquid that passes through the flow meter. This is achieved by repeatedly entrapping fluid in order to measure its flow. This process can be thought of as repeatedly filling a bucket with fluid before dumping the contents downstream. The number of times that a bucket is filled and emptied is indicative of the flow through the flow meter. They give very accurate information and are generally used for reproduction and accounting purposes. There are the advantages of PDM and disadvantages of PDM. The first advantages of PDM is low to medium initial setup cost, and the second is can be used in viscous liquid flow. And disadvantages of PDM is higher maintenance cost than the other non-obstructive flow meters. And the second one is high pressure drop due to its total obstruction of the flow path. And the third one is not suitable for low flow rate. And the last one is very low tolerance to suspension in flow particles larger than 100 need to be filtered before the liquid enters the flow meter. Examples of the positive displacement meters. Oscillating piston flow meters use a precision machined chamber containing a cylindrical piston that oscillates as liquid flows. The piston central shaft is constrained to run in a circular groove in the chamber, resulting in an off-center rotating motion as the liquid sequentially enters and exits compartments machined into the underside of the piston. Notating disk flow meters. It's one of the most common types of positive displacement flow meter. They operate by having a disk mounted to a central ball. When fluid enters the chamber, it causes the disk to wobble, notate, transferring the displaced volume to the register. Oval gear flow meters. The oval-shaped gears are used to sweep out an exact volume of a liquid passing through the flow measurement chamber during each rotation. The flow rate can be calculated by measuring the rotation speed. Roots flow meter. The Roots flow meter is similar in many respects to the oval gear flow meter. A design is shown where two lobed impellers rotate in opposite directions to each other within the body housing. Multi-piston flow meters. Piston flow meters of either single or multiple designs find widespread use in fuel flow meter dispensing and the low flow measurement of light hydrocarbons. Birotor flow meters. Birotor flow meters features two precisely machined rotating members known as helical rotors, which rotate and mesh within the meter's interior housing in order to form a flow measuring chamber of known volume which may be used to accurately determine flow measurement as a function of the rotor's velocity. Secondary or rate method. A flow meter can be defined as one the fluid passing through primary element in a continuous stream. Rate of flow means quantity of flow per unit of time. Obstruction meter are devices which reduce flow area when installed in a pipe flow. This creates pressure drop across the meter. Different types of There are different types of obstruction meter. The first one is orifice meter, venturimeter, flow nozzle, retainer. Orifice meter in an orifice type flow meter, an orifice plate is placed in the pipe as shown in the figure. The pressure is dropped suddenly when the fluid passes the orifice and continues to drop until vena contracta is reached. It is a result of the increase in velocity of the fluid passing through the reduced area. Venturimeter. It is head-type flow meter. It follows Bernoulli's theorem. It works on the principle that by reducing the cross-sectional area of the flow passage, a differential pressure is created. Our flow measurement instruments, which use a converging section of pipe to give an increase in the flow velocity and a corresponding pressure drop from which the flow rate can be ded- deduced. Typical Venturi restriction. There are flow direction, Venturi tube, and flow direction. A Venturi creates a constriction within a pipe, classically an hourglass shape, that va- that varies the flow characteristics of a fluid, either liquid or gas, traveling through the tube. As the fluid velocity in the throat is increased, there is a consequential drop in pressure. Italian scientist Giovanni B. Venturi, 1746–1822, was the first to observe this phenomenon. Equation of Bernoulli's theorem. There are equation of Bernoulli's theorem. Venturi meter consists of converging conical section, cylindrical throat, diverging section. Flow nozzles. A flow nozzle which is held between flanges of pipe carrying the fluid whose flow rate is being measured. The flow nozzle's area is minimum and its stroke. It is a flow tube consisting a smooth convergent section leading to a cylindrical throat area. The throat is the smallest section of the nozzle. Pressure taps are located on the upstream side of the nozzle plate and on the downstream side of the nozzle outlet. They may be in the form of an annular ring, i.e. equally spaced holes connected together which open into the pipeline, or in the form of the single holes drilled into the pipeline. As the fluid passes through the nozzle, the obstruction causes the velocity of the fluid to increase while its static pressure decreases simultaneously at the point of the maximum convergence, i.e. at the vena contracta. The velocity is at its maximum and the pressure is at minimum. As the fluid exits the nozzles, its flow expands, and the velocity reduces and the pressure rises again. This difference in the pressure before and after primary element is measured using differential pressure transmitters, also called secondary elements. Bernoulli's equation is used to determine that the pressure differential is proportional to the square of the flow rate. The flow rate is therefore calculated as follows: Q Q2 equal K dP, where Q is equal flow rate of the liquid, and the K constant value for the particular nozzle. dP is equal to pressure differential. Types of flow nozzles. ISA 1932 with corner tops, wheeled-in type. It was developed by the International Organization for Standardization (ISO). It is widely used in the high pressure and high temperature applications in pipe diameters less than 2 inches. The corner taps are located in the upstream, and the downstream flanges holding the nozzle. Wheeled-in type of nozzles is intended for permanent installation in a pipe. Number 2. ASME. Long radius low beta ratio 0.20 to be 0.5 with throat top flange type. It is extensively used in the power industry thanks to the highly accurate measurement capability and easy installation for the throat tops, which are located in the cylindrical portion of the nozzle. They are fitted into the pipe walls into the distance of one pipe diameter on the upstream side and a half pipe diameter on the downstream side. Rot- rotameter. The rotameter works as a constant pressure drop variable area meter. That is, the pressure drop is always constant, and the area of obstruction is changed. Teaching equipment fluid mechanics flow measurement. There are this is my video clips. And once again, sir, that's all. Thank you.